We're going on now to topic 3 of chapter 2, and there's a couple of things I'd like to remind you of. Back in chapter 5, I had this up here, which were the major formulas. I may not have had them all, but let's just review them. For number 1, this is the standard form of the linear equation in two variables, x and y. If you solve for the letter y by transposing this and then dividing by b, in a sense, it'll then be in this form, which is slope-intercept form, where the m is the slope and the y-intercept is b. We had just gone over that in section 2. And then we reviewed this formula in section 2, which is the slope. If you have two ordered pairs, one you designate as sub 1s and the other as sub 2s, put it in this formula, it gives you the slope. Now, formula 4 we went over lightly, and we're going to go over that in section 4 of chapter 2. And that is, if you know the slope and you have one point of an ordered pair, then you just plug it in and then it will give you the formula number 2 after solving it. And then formula 5 is a special formula. It's in standard form, but it's for a horizontal line right here. And it looks like that. And it's going through the y-intercept, which is your B point. Now, in formula 6, this is a special formula of a vertical line, which gets it to go through a vertical line, well, as a vertical line, at point A, which is your x-intercept. And we said sometimes you could write the ordered pair as A comma B, which is x comma y, where the A is your x-intercept and your B is your y-intercept. And I just added a couple of things that you'll be finding out. This is sort of an introduction here. The slope of a horizontal line is 0. All horizontal lines have the slope of 0. And again, they go through the y-axis at point B. Whatever value they give here, that's your y-intercept. This one is probably like y equals 2. If that was y equals 2, then that's 2. There's your horizontal line. Slope is 0. And for this vertical line, this is probably x equals a negative 2, which is right about there. Okay. Now, two other things we're going to be doing as we talk about parallel and perpendicular lines. If the slopes are the same, we can do that here. If the slopes are the same, and this slope is this one, and this slope is this one, and these slopes are the same. I didn't make them too great, but this is, and then the y-intercepts are different, then the lines are going to be parallel. Slopes are the same, y-intercepts are not the same, the lines are parallel. And for this one, if you have the slopes, and this one, let's say, is 1/2, and this other line coming into it is about a negative 2, then the angle that they make where they intersect is actually perpendicular. These slopes are perpendicular. And so this would be a 1/2, And if we multiplied 1/2 by the other slope, which is a -2/1, and the product of that is a -1, if the product of your slopes is a -1, then the lines are perpendicular. So this is like a little mini lesson of what we're going to do as we go through this. So with that in mind, let's continue. So when you are graphing horizontal lines and vertical lines, again, we're going to use the formulas that we have, and it will be for a horizontal line, the basic formula is y equals b. That's formula 5. And for a vertical line, it's formula 6. X equals a. Now, this is going to be your y-intercept. This is going to be your x-intercept. So this is going to be y equals 2, and the graph of it, y equals 2, is a horizontal line. You can put some other points in there, but it's a horizontal line going through your y-intercept, which is right there, 0, 2. Okay? And the slope of and by the way, the slope of a horizontal line was 0. The slope of a vertical line is undefined. And now we're going to graph this, and I happen to pick out that point. X equals a. This is your x-intercept. And if you do various points, it'll be a vertical line going through a, which was a -2. So x equals a -2 is a vertical line going through -2. They're making it a tad more complicated here, but that's okay. And again, x equals a, it's going through the x-intercept. This is the official way to write the x-intercept. Okay, here they're asking us to find the slope of each line and we can also graph it as well. So we're going to solve this equation for y. We get 4y. I'm going to subtract 3 from both sides and get 12. Y equals, divide both sides by 4 is 3. So the graph of this line will be a line 1, 2, 3. Oh, I'm not doing that very well. Let me use my line tool here. There we go. A horizontal line that's off to the side a little bit. But this is your graph of this equation, and the slope is 0. Now for this one, we're going to solve for x by dividing both sides by 5. We get x equals 4. And let me make a nice graph for you guys here. And it's going to be a vertical line going through 4. 1, 2, 3, 4. And when you do it in MATLAB, you just click here and then any other place. And the slope of this vertical line is undefined. So there's our first equation, y equals 3, which we did. and the slope of the line is 0. It's horizontal. And the slope of the vertical line, x equals 4, is going to be undefined. Okay. Now, here is something that I may or may not have mentioned earlier. And whenever they ask us to graph something using the intercepts, what we want you to do is make this special T-chart. This is called, it's my own invention, an X and Y intercept T-chart, where you put a 0 there and a 0 there. Now, whatever value you're going to get for Y here is going to be your B. And whatever value you get for your X here is going to be an A. So this is your Y-intercept, and this is your X-intercept. So keeping that in mind, let's go on. So again, using our special technique, oop, got the wrong one. Here we go. X and Y intercept T-chart. Now if X is 0, this is going to be a 0 here. 5 times 0 is 0. So divide both sides here by 2. We get Y is 5. Now if Y is 0, we're going to divide both sides by 5. X is 2. So we make a little graph. And we now plot our intercepts, 0, 5. So 1, 2, 3, 4, 5. We put a dot right there. 2, 0. 1, 2. A dot right there. Take your line, and there is your graph. And there's your y-intercept, and there's your x-intercept using this special T-chart. Now they go on a little bit differently, make it a little tedious. I'd like to keep it easy. And they don't use that T-chart. I like the T-chart. They get the same answers. And there's the graph. Your y-intercept is at 5, your x-intercept is at 2. And I think a T-chart would be much better than all of this. Well, actually, it's very similar. It's just how you apply it. Okay, again, another example. So what are we going to do here? We're going to make a T-chart. And it's the X and Y T-chart. Intercept T-chart. That's how you start. Now, if X is 0, 3 times 0 is 0, this is going to be a -2. Divide both sides by a -4. And if this is 0, now here it's a little tricky because it comes out as a fraction, but that's okay. That's going to be 8/3. So this is 0. We're going to divide both sides by 3. We get 8/3. Now 8/3 is 2 and 2/3. If you want to convert it to a mixed number. Now we're going to graph it. So we're going to go 0, -2. So there's a 0, there's a -1, there's a -2. I'm making them big so we have some room. Now I need 2 and 2/3. So there's 1, there's 2, there's 3. So 2 and 2/3 is right about there. And you now take your line And there is your graph. Again, it's easier when you do MATLAB. Again, you're going to put a dot there, and hopefully they have it at thirds. Okay? Now, if you're ever stuck, what would be your backup? Well, your backup would be to take this equation that's in standard form and solve it for y. Put it in slope-intercept form. So I brought my y over to the other side here. It became a positive 4y. Brought the 8 over, it became a negative 8. Then I divided everything by 4. And I get this. And then if I rewrite it, y equals 4/3 x. This is my slope, and there's my y-intercept. So I can plot my y-intercept here as a -2. Now I'm going to go over 1, 2, 3, 4. Now I'm going to go up 3. 1, 2, 3. And there's my slope in a graph. And notice it's going through here at 2 2/3. Doesn't go through the grid at that point. So if you can't get to the grid that way, you can do it this way. This is a workaround. Over 4, up 3. This is the technique we just had. Okay, that's a workaround. So let's check out what they're going to give us here. So we have the y-intercept and we have the x-intercept. So when we go to graph it, we want to find, let's say, a third point. Again, that's their way of doing it. So you got 3. So there's your y-intercept, there's your x-intercept, and you have one other point. That's making another kind of t-chart. So notice it didn't go there, but if we went over 4, up 3, that's the point that we found when we solved it for the letter y and used slope-intercept to graph it. All right. Okay, parallel and perpendicular lines. I went through that with you a little bit in the beginning, but let's go and check it out here. So here they're asking us to determine whether the graphs are parallel or not. And how do we do that? Well, the strategy would be to put both equations in slope-intercept form. So this one is already. So our slope here is 3/2, and our y-intercept is 3. So let's find the other. So what I did is I transposed the -2y to this side, so I had a positive y. Transpose this to this side, so I have a positive 5. Divided everything by 2. And now what I'm going to do is compare my slopes. So here's the slope of this one, and here's the slope of this one. And what do you see about the slopes? They're the same. Well, how about your y-intercept? Here it's 5/2, and here it's 3, which would be 6/2. Are they the same? No. So these lines are parallel. Okay, there's the slope. And again, I don't like the fractions like this. It's a little hard to follow. Okay, now we said that if lines are perpendicular, if we multiplied their slopes and got a -1, they're perpendicular. Okay, let's try one out here. Okay, so here we know this one So here we see that this slope is a negative 2/3, and this slope is a positive 3/2. Remember, I had to solve for y. And everything cancels out here, and you're left with a -1. So these are perpendicular. And that's what we had. So the first thing you have to do is find the slope by solving for the letter y. Y equals something, you put it in slope intercept form. Then you multiply the slopes, and if you get a -1, they are perpendicular. Okay. Write a slope-intercept equation for the lines whose graph is described. Parallel to this. So here we have an equation in standard form. So I'm going to transpose the 5y, becomes a positive 5y. Transpose the 3 becomes a -3. Divide everything by 5, and I now have the slope of a line that would be parallel. But they wanted to go through this point, which happens to be the y-intercept. So my new equation will be y equals the same slope, 4/5 x, but goes through the y-intercept of -5. Now here they want us to do a line that is perpendicular to this. So it's the same equation, but what would our slope be in order to be perpendicular? Well, it's going to be what we call the negative reciprocal. We have to change the sign. Here it's positive, so we make it negative. And we just flip this over. 5/4 x. And it's going through this y-intercept. So this would be the equation of a line that's parallel to this. This is an equation of a line that's perpendicular. Once we found the slope, we take the negative reciprocal of it, because if we multiply these two numbers, it would give us a -1. So they're going to tell us what to do. We have to find the slope. So there's our first slope, 4/5. Slope is 4/5. And then we have to have it go through the y-intercept. So there's our first equation. Usually they don't put the 4 up there, they put it after the division bar, but it's okay there as well. And now again, if our initial slope is 4/5, we have to find the negative reciprocal, which we have there, and then we write the rest of the equation. Okay. And finally, they're giving us standard form. This was our equation 1. And they're asking us to determine if these equations are linear or not. Are they a straight line? Well, the key is that the letters are in the numerator, and no letter is greater than to the first degree. That is, it's x to the first. So this one's linear. That's slope-intercept. This one is actually an equation of a parabola. So this is not linear. And this is an equation of a horizontal line. When we solve for y, it's going to be y equals 7/2 or 3.5. This is linear. And you could also put them into standard form by taking the 4x term, bringing it over to the other side, transposing it. Now this is in standard form. Usually they like the a term to be positive, but that's okay. And this is the parabola here. So it's not linear. And this is a horizontal line. And there it is. Okay, that wrapped this up. Tried to make it a little bit shorter, but lots of stuff going on. And through practice and doing your quiz me, that's how you gain your mastery.